And then I'd like to introduce our speakers. Today we have Anne Bikle. She's a science writer, public speaker, focuses on the connections between people, plants, food, health, and the environment. She has a bad case of plant lust, apparently. It takes her into her garden where she coaxes plants into rambunctious growth and nurses them back from the edge of death with her regenerative gardening practices. Anne's work has appeared in magazines, newspapers, radio, and her soil building gardening practices have been featured in independent and documentary films. Anne's husband, David Montgomery, is a MacArthur Fellow and professor of geomorphology at the University of Washington. He's an internationally recognized geologist who studies the effects of geological processes on ecological systems and human societies. His work has been featured in documentary films also, network, cable news, and on TV shows such as Nova, PBS, Fox and Friends, and All Things Considered. David is the author of Dirt, The Erosion of Civilization, with a truly horrifying photograph on the cover of the Dust Bowl, and Growing a Revolution, Bringing Our Soil Back to Life, which forms pretty much the basis for today's speech. And Anne and David have also co-authored The Hidden Half of Nature, From Garden to Gut. The book explores humanity's tangled relationship with the microbial world through the lens of agriculture and medicine. And their latest collaboration, very exciting, What Your Food Ate, How to Heal the Land and Reclaim Our Health. That will be published late spring of 2022. So without further ado, please welcome David Montgomery and Anne Bikle. David's going to kick off our presentation today. Welcome, everybody.
Okay, well, thank you, Gail. Welcome, and we'll see you shortly. I'm going to be doing the first half of the talk today, and then I'm going to be turning it over to Anne. I've had the great fortune to marry a master gardener and get to enjoy her garden, but the plants and the soil restoration that you'll be seeing when it gets to her part of the talk is mostly her doing. She's the mastermind and the gardener. I'm a geologist by training, and what I'm going to be doing is helping set the stage for thinking about soil restoration, how to do it, why is it important, how to basically do it, and then hand off to Anne to talk more about the biology and the science behind it and the applications to home gardening. So let me share my screen here and get started in terms of a presentation. So what you should be seeing now are the three book covers that lead up to the one that we're releasing this spring. This is what Anne and I refer to as our Dirt Trilogy. About 15 years ago or so, when I wrote Dirt, the Erosion of Civilizations, I never thought that we'd be writing more books about soil. But we're going to take you today on a bit of a trip through the intellectual journey that Anne and I have been on together as we started looking into the role of how soils and their health have influenced human societies in the past, the science behind that, how that could help reform farming practices, and what it might actually mean for human health in our new book. So Dirt tells the history of sort of the look back through societies and how the way people treated the land affected the way the land treated societies and civilization after civilization. The Hidden Half of Nature talks about investigates the role of microbial life, the bacteria and fungi in the soil, in soil fertility. It highlights how important that is for our thinking about the soil. And Growing a Revolution takes the history from Dirt and the lessons of science from the Hidden Half of Nature to look at the question of whether we can actually reform farming practices to restore fertility to the world's agricultural land. And my part of the story is to basically do a little bit of setup for Anne. And one of the first pieces that I like to start with is just how important the way that we treat the soil actually is. Because if we're thinking about how we're going to feed the world in 2100 or 2200 or 2500, the kind of timescales over which a geologist like myself might consider farming sustainable, centuries, not just years or decades, it's very sobering to note that the UN Global State of the Soil Assessment from back in 2015, not all that long ago, wrote that humanity, the global us, loses about 0.3% of our global food production capacity each year to soil erosion and soil degradation, the loss of the soil and the degradation of its fertility. Now, 0.3% is not a terribly big number. I mean, that's kind of like the interest rates we're all getting on our savings accounts these days. It takes a while for that to add up to any kind of a real increase. But when you deal with decades and centuries, that 0.3% can really add up. And at the pace of 0.3% a year, we'd be on track with modern conventional farming to degrade roughly a third of our ability to feed ourselves over the coming century, simply by degrading the fertility of the land. The historical estimates that I put together in Dirt look at how we've already degraded, roughly a third of the world's farmland through soil degradation in the past. You put those two numbers together and it paints a sobering picture of the world's ability to feed itself in 2100 unless we change the way we do things. So I'm going to start with the backwards look in terms of Dirt. It's the kind of the depressing part of the talk. We'll get to the optimistic part a little later. And Anne will get to the relevance to home gardens and the science of biology that is so exciting that's been unfolding in the last couple decades. But when we look at the backstory of civilization after civilization, there's a common element where if we look at soil erosion and soil degradation played a key role in the demise of ancient civilizations that you can trace back to, actually really some of the dawn of agriculture regions in Mesopotamia, but also to Bronze Age Europe, classical Greece, Rome, the southern United States. The list really goes on, and I tried to go through and do a historian's cataloging of the way that land degradation impacted societies in the past in Dirt. But the story that you generally hear in environmental histories is that deforestation caused soil erosion, which helped to undermine societies. It's not a new idea that soil erosion impacted societies in the past. But what I found in looking into the story, both through the archaeological record and the record literally written in the land, the state of the soils in the areas that had been degraded and the native soil scraps that were left in those areas, I put together a story in Dirt that really had a different focus. And the villain of that story was actually the plow, a fundamental agricultural icon. When we think of what do farmers do, plowing and tillage comes to mind immediately. But the problem with plow-based agriculture over the long run is that fundamentally alters the balance between soil production and soil erosion on the surface of the earth and the lands that we actually use to feed ourselves. And how does that work? Well, think about all the native grasslands and forests that you may have ever wandered around, or just think about your local environment. Most places on earth are clothed in soil, clothed in plants and clothed in soil, other than bare rock outcrops, for which soil erosion is not a problem because there's hardly any soil. So where a glacier scraped off the soil and left you bare rock, now thousands of years later, the challenge for agriculture is converting that rock into soil. But for the world's farmlands that we've long relied on for our sustenance, the problem of tillage is that it basically leaves the ground surface bare and vulnerable to erosion for some period of time after a plow on a freshly plowed field. And that can lead to soil erosion racing ahead of soil production. Nature builds soil slowly, and soil can bleed off fairly fast off of plowed agricultural fields. But besides just soil erosion, there's another potential problem with soil degradation that relates to the loss of soil organic matter. And this soil over here on the right is a soil from a tobacco plantation in North Carolina. That is a soil that's developed on the native geological materials. It's essentially 10 million year old beach sand in this particular area. And it looks a lot like beach sand with some crusty salts in it. This is basically what the soil looks like after 100 years of conventional agriculture in the Piedmont or hill country of North Carolina. If you go just over the fence line, however, to the neighboring farm, to the neighboring forest, which was a farm 150 years ago, but was abandoned and went back to forest and now has trees that are about 3/4 of a meter, 2 feet in diameter. So it's essentially a restored forest. The soil on that forest patch looks like this nice sort of chocolate cake color. There's organic matter that you can see in it when you dig a shovel into it. Life forms scurry out of the way. This is actually fairly close to the soil kind of descriptions that you read in the journals of early colonial settlers and plantation owners in this part of North Carolina. And this illustrates pretty well what happens when you take a native forest soil, treat it with conventional agricultural practices for 100 years, you turn this chocolate cake into khaki beach sand. The parent material is the same. They're developed on the same underlying material. The difference has been in the same climate. The difference is how people have treated the land for the last 100 years. And that change in color from chocolate brown to khaki is pretty much entirely due to the loss of soil organic matter. And as Ann will be talking about a little later, that organic matter in the soil, that carbon that's circulating between plants and the soil and soil life and back into plants, is actually the currency that helps to drive a lot of the processes that maintain the health and fertility of our land. So how bad has been the loss of soil organic matter on North American farmland soils? Well, this paper in the journal Sustainability from back in 2015 wrote that the soil organic matter content, which is basically the soil carbon content of many soils in North America, is about half the level present at the time when they were first converted from forests or prairies to farmlands. In other words, we've run down the carbon batteries of our farmland soils by about 50% in just a couple hundred years of post-colonial agriculture across North America. So soil degradation involves both the degradation of soil organic matter and the physical loss of soil itself from erosion. Well, how bad is the problem of soil erosion at a global scale? That's one of the questions I wrestled with in Dirt. And what I did to address that today, rather than in the historical and ancient records, is to vacuum up all the data that I could find from studies that had documented how fast soils are eroding on farms around the world. And what I came up with was about 1,400 different studies that the average value of what farms are, how much soil farms are losing today as a global average for conventional agriculture is about 1.5 millimeters a year, that red number at the top of the screen. At that rate, it takes about 20 years to erode an inch of soil. That's screamingly fast in geological terms. To be fair, our fingernails grow faster than 1 millimeter or 2 a year. But if you keep that pace up in terms of soil loss over time, it can outpace the ability of nature to replace that soil. And so one of the things I did in researching Dirt is I also vacuumed up the data I could find and from academic sources and in the library on how fast nature makes soil. And that's that blue number at the bottom of the screen, about 2% of a millimeter a year. And you'll notice that there's about a 2 order of magnitude difference between that blue and that red number. At the pace that nature makes soil, it takes 500 to 1,000 years to replace that inch of soil that can be lost in a decade or two of conventional farming. Therein lies the problem. If you're interested in the data, the paper that at the bottom of the screen has all the data in it from all the studies that I looked at, but I compiled it all so nobody would have to go through that exercise again. It illustrates a big problem that with conventional farming practices, we're degrading soil organic matter and we're losing the soil faster than nature can replace it. And what I've just given you is essentially the data that you would take to calculate for yourself what the average longevity of an agricultural civilization would be. Because that net loss of soil of roughly 1 millimeter a year, and I'm being conservative there relative to the numbers that I just showed you, it implies that you could erode off a typical 0.5 meter to 1 meter thick hill slope soil, 1 to 1.5 feet, or 1.5 feet to 3 foot thick soil that's typical of hillsides around the world, in roughly 500 to 1,000 years. That's pretty fast to a geologist, but it's also approximately the lifespan of most major agricultural civilizations outside of major river floodplains. And that caveat of major river floodplains is important because I hope you're sitting there at home thinking, well, Dave, what about the agriculture in the Middle East along the Tigris and the Euphrates, or along the Nile, or the big rivers of India or China, the Indus and the Brahmaputra and the lowland rivers of China. These are all places where agriculture has been practiced for thousands of years, and human populations with a relatively consistent cultural continuity have persisted. Well, there's a reason for that. And that reason is the physical geography of those areas. Those are all major river floodplains. And what happens on a floodplain? Well, it's hidden right there. That's in the name of it. They flood. And what do floods bring? Well, not just water, but sediment, silt, sand, and clay. And so if you're farming on a floodplain and nature is periodically, on the average every year or two, in fact, rivers will overtop their banks and flood their floodplains. That water will basically bring new minerals that can refresh the fertility of the land. And so the problem of land degradation is one that really comes to home to roost when civilizations start farming outside of the major river floodplains, and when the population rises to the point where it depends on production from areas outside of floodplains, and the society degrades the hill slope soils that are providing that freeboard. That's where societies run into big problems. And that's the end of the depressing part of the talk, because what I started thinking about and worrying about when I was finishing writing Dirt was whether or not this could be reversed. Could we restore soil on realistic timeframes and actually reverse the historical pattern of land degradation? And that's something that I really started to learn in our own yard, really from watching Anne in her garden, as she'll get to in a little bit. But when she shows you how much she actually restored fertility to the land in our yard, you'll be it basically. Well, when we realized how fast she was turning khaki soil back into rich black, very fertile earth in our yard, it motivated the question of, well, could we do this on farms around the world? And so after working with her on the hidden half of nature, as she'll tell you about, I went and visited farms around the world that had basically done to their farm what Anne had done to our yard in turning degraded, worn out soil like this khaki stuff into richer chocolate cake like the stuff on the right there from a farm in Ohio. And what I found after visiting farms in equatorial Africa, Central America, and across North America, who had restored fertility to degraded land, who turned that khaki kind of stuff back into dark brown, really rich, fertile soil, was that the farmers who did this all adopted practices that shared the principles of conservation agriculture. And what those three principles are to minimally disturb the soil or don't disturb it at all. And what that translates into in terms of agriculture is no-till farming. And I'll describe more about how that can translate into gardening activities. But don't disturb the soil is sort of a cardinal rule of rapid soil restoration. And maintain a permanent ground cover. And for farms, that means cover crops, whether in between crops, the cash crops in a farmer's rotation, or in between the rows on the ground, literally at the same time in a field. And to adopt diverse rotations, not just growing one or two things, but growing at least 4 or 5 different kinds of crops, either in a field at the same time as some of the subsistence farms in Africa that I visited, or 4 or 5 crops in a rotation of the way that the commodity crop farms across North America did. And these 3 principles, minimal disturbance, maintain a permanent ground cover through cover crops, and grow a diversity of crops, really translate into a recipe for supporting the beneficial life in the soil, as Anne will talk more about. That's what all those little microbes are doing around the screen there to remind me to basically mention that part. And the other part is that those 3 principles turn out to be pretty much the exact opposite of what us academics have trained farmers to do, taught farmers to do for the last 100 years, where it's been emphasized that we engage in intensive tilling, rely on agrochemicals for maintaining fertility of the land rather than cover crops, and to specialize in a minimalist number of crops and even 2 crop rotations like corn and soybeans. So the principles for rebuilding soil fertility turn out to be the opposite of what those that underpin modern conventional agriculture, but they also turn out to be ones that can work really rapidly and well to restore fertility to the land. This gives you an example of 2 soils from a farm in Carroll, Ohio, where the soil on the right is what the soil was like back in 1971 when the farmer, David Brandt, first started to experiment with going to no-till, and in subsequent years he adopted cover cropping and then diversified his cover crops. He grows wheat, corn, and soybeans for the North American commodity crop markets, but he's managed in so doing to turn his soil from this khaki clay to this really rich chocolate cake. It's the same parent material, the Cardington clay soil. The difference is the farmer, the way he's treated his land. Increase the soil organic matter content, you can see that in the color, but also notice the sort of the structure and the holes in the chocolate cake over there on the left, and the smearing of the face on the one on the right. These soils, despite sharing the same geology, have completely different agronomic characteristics. And the farmer has basically restored fertility to his land, and he did it in a couple decades. And he's not alone. These show you the hands of North Dakota farmer and rancher Gabe Brown showing off the soil on a piece of his market garden where he's turned soil that used to look like his neighbor's soil down over here in his left hand held a little lower, which is not bad soil in this part of the world. But notice the color difference. He's taken stuff from about 4 or 5% organic matter up to about 10% or so. He's basically taken his soil and put more carbon in it than the native prairie soil held. And he did it as a consequence of intensive and highly profitable farming. These kinds of changes are what sent me into the optimistic phase of thinking about the problem of soil health and land degradation, because these farmers who farmed in ways that were regenerative, that rebuilt soil fertility, that rebuilt the health and fertility of their land, they were able to use far less fertilizer, pesticide, and fossil fuels for reasons that Ann will go into, basically through restoring beneficial life forms in the soil. They didn't need as much fertilizer or pesticide and fossil fuel. They also basically maintained comparable yields to their conventional neighbors. This is not a question of trading off environmental quality for food production to feed a hungry world. It's really the interests of rebuilding soil fertility, feeding the world in the future, and reducing the environmental footprint of farming. They all align when we think about timeframes beyond an individual harvest cycle, and we think about maintaining land fertility over decades to centuries. What turned me into an optimist is this combination of spending less to grow just as much led to higher farmer profits, a better bottom line for farmers. These ideas are catching on across wide swaths of the farming world, in not just North America, but around the world. And it can also result in increased soil carbon and carbon sequestration. Taking carbon from the atmosphere via photosynthesis to build soil organic matter is a net positive for the climate, but it also can impart a resilience to farm fields by enhancing water retention in the soil, and results in less offsite pollution. If you're using less nitrogen fertilizer, less of it's going to be available to run off the farms and get into people's water supplies or the Gulf of Mexico. So there's lots of benefits for improving healthy soil. But the one that we really wrestle with in our new book, What Your Food Ate, is the one that is exciting us most at the moment. And that's looking at what do these regenerative practices that build soil organic matter, restore fertility to the land, what do they actually do to our food supply and the quality of our food supply? So in writing What Your Food Ate, Ann and I engaged in a little bit of a scientific experiment. It's not huge numbers, but we took 10 pairs of neighboring regenerative and conventional farms from across the US, as you can see on the map here, where we took farms that had the same soil type and crop variety that were next to each other in each of those locations, and had the farmers grow either corn, soy, sorghum, peas, or cabbage, the same crop variety, literally across the fence line from one another. But one farmer had been regenerative for at least 5 or 10 years. The other farmer had been conventional for longer than that. What was the difference, we wanted to know, in the quality of both their soils and also in the food that they were growing on their farms? And this set of box and whisker plots shows you the results for the soils. And they're fairly simple to read. The two, well, let's start with the one on the left. So we're looking at the percent soil organic matter in the soil is the y-axis. And we're comparing the regenerative farms to the conventional farms. And so on average, the regenerative farms had roughly twice the amount of soil organic matter. If we look at what's something called the Haney soil test, it's a test of soil health. So it looks at both soil organic matter, but also the life in the soil. So think of it as an index of just how ecologically buzzing the soil is, how many life forms, how many bacteria and fungi there are in the soil. Again, the regenerative farms outperformed the conventional one by a fair margin. And if we look at the ratios of these two comparisons over here on the left, the regenerative farms had twice the soil organic matter and 3 times the soil health score. So what that's basically saying is that, yes, these regenerative farms across the board had improved the health and fertility of their land, pretty dramatically for actually just a decade of adopting regenerative farms. They basically reversed the degradation that historically had happened on across North American farmlands. But what happened to their food? So these are examples over here on the right of different nutrients: calcium, copper, potassium, phosphorus, and zinc in some of the crops, showing some of the big differences that we saw between those paired farms, ranging from 43% more calcium in the regenerative sorghum than the conventional sorghum, twice the copper in the conventional sorghum, twice the phosphorus in the twice the copper in the regenerative sorghum, twice the phosphorus in the regenerative cabbage. Point being, these numbers are all positive And the mineral density, the nutrient density of the regenerative crops was higher than that for the conventional ones, and higher by roughly the same margin as the historical decline in nutrients that people have documented and that we review in What Your Food Ate amounted to. So in other words, these regenerative practices appear to be able to put things back in our crops that conventional farming practices have essentially resulted in losses from. And it's not just, and these changes in soil fertility don't just relate to the to what's in our crops, but also to the livestock that graze on those crops. This shows you a comparison from Brown's Ranch, one of the regenerative ranches, the one in North Dakota, in Bismarck, North Dakota, where I showed you Gabe Brown's hands. This is the comparison of beef and pork off of his ranch and farm with a regional natural brown. So their brand is Nourished by Nature, so it's these light blue lines. A regional grass-fed health-promoting brand is shown in the darker blue, and conventionally store-bought, conventionally produced livestock beef and pork is shown in the red. And what we're looking at is on the left is the total omega-3 fat content. Omega-3 fats help to quell inflammation. They are considered to be healthful. And what you'll notice is that the regenerative beef and pork both had several times the omega-3s than the conventional. And better than the regional health promoting grass-fed brand as well. The regenerative ones was 100% grass-fed, grazing on restored native prairie with that rich, beautiful soil that we were seeing. In terms of the omega-6 to omega-3 ratio, which is a ratio of omega-6 fats to omega-3 fats, you want a low value of that ratio. You want a rough parity between omega-6s and 3s, again, for reasons we go deeply into in What Your Food Ate. But just look at the differences here, where the regenerative beef had a ratio, a rough balance of 1-to-1 of omega-6s to 3s, which is thought to be representative of the ancestral human diet and is very similar to what is present in wild game. The conventional beef had a ratio of about 6-to-1. The conventional pork had a ratio of about 20-to-1. What's the difference? Grains are really rich in omega-6s and grasses are rich in omega-3s. So when you have livestock that's grazing on healthy live forages, they tend to have a low omega-6 to 3 ratio and a high omega-3 content. If you have livestock that's in a feedlot that's eating corn and soybeans, they are going to have a high omega-6 to 3 ratio and a low omega-3 content. Again, the regenerative products were much more healthful in terms of their nutritional composition than those grown on the conventional fields. So I'm going to sum up here and on my part and hand it off to Anne to get into the biology and what she did in our yard, as well as some more follow-up on the new book. But there's a slogan that Anne and I came up with in Writing Growing a Revolution that really characterizes what the key elements of regenerative farming are: ditch the plow, cover up, and grow diversity. Basically, it translates into cultivate the beneficial life in the soil if you really want to cultivate and soil fertility and restore soil health to the world's farmlands. So I will hand it off here to Anne at this point and let her back in the room so she can basically tell you the story of the hidden half of nature and a little bit more about the new book. So it's all yours.
Right. All right. Thank you, Dave. So what I'm going to do now is just share with you kind of the story behind the hidden half of nature. And this book came out of not just a place close to home, but actually right at our house. So this is a house that David and I acquired in North Seattle some years ago. And it was a fixer-upper. There were some things that we needed to do inside, but also, indeed, there were some things that we needed to do outside. And one of the things that really attracted us to this house was this vast side yard that you can see right here. And I had been longing for a garden much of my, early adult life. And this to me said, this is the place that we might be able to start something like that. It took a while to get going. It required a lot of scheming and dreaming on my part. This was in the days where you used to get photographs and make a montage of them. And Dave used to joke with me that what is going on here in the living room that looks like ransom notes from some crazy botanist, all these cut up things, all these words, things like that. But what I liked about this process, and I'm sure many of you have done something like this, is it gives you an idea of what you're going to fix up, what it might look like, and how you might go about it. And the day had finally dawned, and it was time to get the plants in the ground. Now, I can see some of you out there thinking, I thought these were soil people. What are they talking about? They've got nothing but dirt. And sadly, that was our realization too. And, as a biologist, I thought, that's Dave's territory. He needs to be, telling us what is going on with the soil, what is going on with the ground. And he in turn thought, no, you're the biologist. You're the one who wanted this garden in the first place. So the long and the short of it is that when you make a mistake, like say, not really checking into your soil before you're going to put plants in it, mistakes can be fixed. And this is pretty much what I learned at this point. And sometimes when you're facing a mistake, a challenge like this, it can send you into a panic and you can get moving really quickly. But I pretty much identified this point in my gardening adventures and escapades as the Organic Matter Chronicles. It was truly the beginning of my education as a real gardener, to begin understanding where's the health of this garden coming from anyway? What are the things that I need to think about? And I had done enough gardening in my past to know that organic matter was going to be playing some kind of role. And as I mentioned, panic can get you moving really quickly. So the first thing I did was got my wheelbarrow, and it was going to be hauling carbon, lots of carbon. So I put flames on the wheelbarrow in hopes that things would move along a bit quicker. And what I did, that slide that I showed of that terrible soil that we began with, as Northwesterners, even here, and even more so these days, you really should not be putting plants in the ground in the middle of August or even late in August, which is years ago where we started with all of this. And I was becoming a slave right away to watering. And the other thing I wanted to do was, I was not interested in doing all of that watering. So I thought I need to get mulch on that, on top of this soil. So I began collecting organic matter. Where from? Anywhere that was close, any organic matter that was cheap or free. And so these are just some examples of the things that I came up with. And down there at the bottom of the screen, you'll see a capital N or a capital C. And that just refers to what primarily these piles of organic matter contain. N for nitrogen or C for carbon. And then of course, some piles like pile A there, that's carbon and nitrogen. That's a mix of wood chips and compost. And so, I'm sure there's better composters than I am out there in the audience. And you may be wondering, well, what about the ratio? What kind of ratios of carbon to nitrogen are you using? And I didn't get real picky about that. You look into the literature on compost, and generally what you find is you want a ratio of somewhere around 30 to 10 parts of carbon to 1 part of nitrogen. So I kind of aimed for something in that ballpark, and it eventually came down to, I just want to have more carbon by 10 times at least, maybe less. It all depends on what kind of materials I'm working with. But any event, I don't ever want to get more nitrogen than carbon. Then you can get kind of a messy situation going. But I also wanted to point out one thing that I learned in all this mulching and composting that I was doing was pile E there on the lower left. That's composted coffee grounds, and it's a nitrogen source. And a lot of people think they tend to sort of associate the color of organic matter with whether it's nitrogen or carbon. And so we think of dark colored things as being sources of carbon. But what's interesting about plant materials, dead plant materials in particular, is that when you get something like a seed, which is what the coffee bean is, right? That's the seed of the coffee plant. Seeds are really rich in nitrogen. So despite the color of coffee grounds, they are really a nitrogen source. And I happen to be, that was a harder sort of organic matter, type of organic matter for me to come by, because you know, we're not Gabe Brown. We don't have herds. We don't have flocks. What I have is composted coffee grounds. And then later on, of course, as we began composting food scraps, I had worm castings, and they were and are some of the finest nitrogen sources that I can think of. I really like them. So that's my little tip for you on compost and coffee beans. So what was I doing with all this stuff anyway? Well, I was mixing them up in that wheelbarrow painted with flames into different kinds of mulches. And what I really, really like as the base of my mulch mix is decaying wood chips. And I know that you islanders probably have ample supplies of wood chips. Here in the city, it's a little harder to come by, but if you make friends with an arborist and you get on their callback list, and if you live close to where they're doing a job, they will dump wood chips into your driveway, yards and yards of them. And like I said, I like this a lot. It's a great substrate for fungi, and it is a good carbon source. And so I could mix nitrogen sources in with all that carbon. There's some evergreen in there from my hinoki, coniferous tree. This is an early summer mix, and so pruning things, young fresh leaves, which actually are another nice nitrogen source. And then lastly, those bits of color in there, that was a bouquet from my neighbor. And so one thing you need to know about me is this: should you give me a bouquet, I will enjoy it for sure, for a few days inside, or until the flowers start to go. And then it's going to go into one of my mulch mixes, and it's going to go back out there on top of the beds. And what another part of the education, my education as a gardener, was that I had thought, because we all know this, right? Oh, we should dig things into the soil. So I laid all these mulches out. And the fact of the matter is, I was so busy watering or attending to other parts of my life or just other things. And I thought, hey, that mulch looks pretty good out there on top of the bed. I'll dig that in later. And I never got around to it. I kind of forgot, and it didn't seem like it was harming anything. And then one time I got around to thinking I was going to dig it in, and part of it had decayed. And I thought, I don't think I need to dig this in. I think I'm just going to put more mulch on top. So this is what was occurring then after maybe 5 to 7 years of layering all of these mulches on top of one another. There you can see the soil that we started with. It's this, you know, poor organic matter containing soil. It's really basically a legacy of the glacial history around here. And then on top, you can see all this organic matter that is kind of dripping into the soil from my mulch mixes. So clearly we're getting some different soils here in the garden. And you may be wondering then, okay, all these changes on top of the ground, on top of the soil, what is going on even further up? Well, here we go, the garden. Now, I love talking to gardening audiences because I know that probably right now, every one of you is thinking about something you love about your garden, some reason that you garden. And for me, for sure, part of it is about just the beauty and the range of colors and these different effects that we can get and how all of this makes us feel. And I hope most of the time we're feeling better. I know that when I get outside and get around my plants, my mood lifts. I like it. And so this is one shot of the garden. And I joke with farmers when I go to farming conferences. Their crops of soybeans and corn and stuff, no, not so beautiful. But that's what they grow. And I say, well, I grow other crops. my perennials, my trees, and so on. And the other thing we love about gardens is the fact that, especially with flowers, we can stand back in awe and wonder at this flower, but then they are a huge part of the insect world and the coevolution between insects and flowers, and in fact, all plants. Mid to late summer, this is what I love to do, is come out and see what is happening, who's visiting, what are they doing? And then, of course, for the food gardeners out there, our veg. We love to grow the veg. I do. And especially in the Northwest, it's so easy to grow these big, rambunctious, leafy greens. We might not be so great at tomatoes, although maybe we will be in the future. But in any event, food is another way of connecting to soil, connecting with our gardens. And what I began to realize, in this journey, is that all these gardening practices, the things that the garden had brought into my life and into Dave's life, it sort of reframed my view of what it was that I had been doing. And sometimes you know how you do things and it doesn't quite have maybe a term for it or a name for it yet, but it feels good. So you just keep doing it. And that I think is the case with how regenerative practices have begun to sweep through the gardening world, just as they have with the farming world. And I got to thinking about that term and what does that mean? And so it's a person who works with words, and which is a frustrating process in and of itself. Sometimes you just go to the dictionary. What does this thing mean? So I did that with regeneration. And here you can see a couple definitions. The first one, most annoying. It's using the word you're trying to learn more about to define the word. And then the second one, certainly in our gardens, we have had this kind of an experience, I believe. We feel better. There's something spiritual. We feel revived. I will buy that as part of this definition. But then this is a definition that really knocked my socks off, especially that last part there in boldface. Regeneration, it's a normal process. So this is what felt best of all, is that all of these things that I was doing in the garden, they should have been happening all along as part of a normal process. And in the farming and gardening world, that normal process is nutrient cycling. This is what we're doing with all of this organic matter. I mean, just think about this. The botanical world, it's been out there for over 400 million years, and it never needed farmers or gardeners or jugs and buckets and bags of stuff to put on the soil. The botanical world, the green bodies of plants had figured this out. So I think what regenerative practices really are is that we are literally getting back in touch with how nature really works and how nutrients cycle back and forth from life to death, and how the soil is really the medium for which much of that happens. And so, okay, I'm here talking about myself as a gardener, but in fact, I was not doing a lot of the heavy lifting, the soil was. And here we have, of course, the form of soil life we've all seen out there. These are the things easy to see. These are our grinders, our chompers, our chewers. They're taking the first crack at organic matter in breaking it down physically into smaller bits. And then you go down sort of in the scale of life and you get to smaller forms. Everything up here, these arthropods, around 1 millimeter in size. And if you have a really good eye, and if you pick up a handful of soil and gaze at it, maybe you'll see some of these things. For sure, if you get a 10-power hand lens, you'll see mesofauna. But here's something you're probably never going to see unless you have a microscope. And this gets down to the microbial level. There in the upper left, that's a clump of bacteria, which is just, chock full of life in the soil with bacteria. And then in the upper right, we've got what that is it's a root hair. And those spherical objects, that kind of fuzzy stuff around the root hair, those are actually the spores of mycorrhizal fungi. And I'll get into a little more about what they do. And then on the lower left, that's just a nematode. And in the lower right there, that actually is another example of mesofauna, little arthropod there. And where I want to take you now, especially with respect to the microbial world, is a place deep beneath our feet. It's a place called the rhizosphere. The rhizosphere, if you were to outline each and every root and root hair around the root system of a plant, that is the rhizosphere. And the rhizosphere is a wild and alive place, in part, actually mostly, because of exudates. What are exudates? Exudates are what plants manufacture inside of their green body, and then they release them into the rhizosphere. So if you enlarge a root tip, as shown in this slide, what you'll see is the rhizosphere around that root hair and the exudates that are flowing out into the rhizosphere. And the rhizosphere is actually where the lion's share of the plant microbiome exists. So these are all of the microbial communities that are so intertwined with the plant that it's really sort of hard to tell where the plant body ends and the microbial body begins. This is a very intimate part of both the microbial world and the botanical world. So as I had mentioned, exudates are flowing out. What are exudates? Carbohydrates, fats, proteins. These are meals for microbes. And with bacteria in particular, they are consuming those exudates, and then they in turn are producing byproducts or metabolites that the plant can take back in. Some of these metabolites are hormones that promote plant growth. So that's pretty interesting, right? The botanical world has farmed out to the microbial world the production of growth hormones that help the plants grow. And in terms of fungi, you'll see up there, as you know, mycorrhizal fungi are connected either actually inside of a plant root or on the outside, and they go far, far, far away from the root system of a plant, and they capture things like phosphorus or zinc or other minerals. And they bring these back, and in exchange for handing over those minerals, they get exudates. So this symbiosis between a plant and the microbial partners there in the rhizosphere, this is one of the oldest and grandest symbioses that we know about in nature. This all began long, long ago when the first plants came out of these watery environments to colonize land. They had these puny, primitive little root systems, and they needed a lot of help. And the microbes were there, and thus they struck up the partnership. So when it comes to the plant body, this here is to let you know that plants are also, of course, photosynthesizing up above ground, and they take about 40% of this energy that they get out of photosynthesis, and they use it to manufacture all of these exudates. You don't need to be a biologist to know that's a lot of energy to be putting toward one thing. This would be like if you took 40% of your paycheck or any other thing that's valuable to you and you set it out for others. So this is how tightly interwoven the plant body above ground even is interwoven with the microbiome below ground. And this is just a picture of fetching fungi there, running out there through the soil to gather things for the plant body. The other thing to let you know about is that there's many aspects of plant defense and health that begin down there in the rhizosphere. If there's an herbivore, an insect herbivore munching above ground, a plant will send signals down to its soil microbiota, and the soil microbiota will begin producing metabolites that the plant can then take back up into the rest of its body that either stimulate other immune activity on the part of the plant, or sometimes it's actual compounds that can help deter pests like this. So that's pretty cool. You don't need jugs and buckets and bags. What you need is a functioning microbiome there. So this is all to say, this is a lot of chatter. This is a lot of communication between the plant and its soil microbiome. And that, my friends, can mean only one thing: plant intelligence. It's not above ground, it's below ground. That is where the plant brain actually is. So how are we going to feed that plant brain? Well, we have some options. You got your fertilizer diet. This is your shown there on the left. This is where the jugs and buckets and bags of N, P, and K come in. They certainly make plants grow. There is no doubt about that. But then look at the root system on that plant. It's kind of paltry. So why? Why is that? Because the plant is getting what it needs through these fertilizers. So it's not dedicating a lot of its photosynthate. These are all the compounds that it produces through photosynthesis. It's not dedicating that to making exudates. It's shunting that into these big fat leaves and fruits and stuff like that. What that means is that paltry root system is not feeding its microbiome. And that means metabolites are short. That's what that bottom box with the purple around it is meant to show you. Fertilizer diet, short on metabolites. So what do we do when we are sort of lacking in all this defensive biology down there? This is then where all of the toxins and the poisons come in to take care of the pests and the pathogens, because the plant is short on sort of its defensive strategy. So contrast that with the soil health diet there on the right, and you can see that organic matter is dripping an adequate amount of N, P, and K into the soil, along with micronutrients, along with buckets and buckets of these microbial metabolites. Because the plant body, it's growing all this biomass, especially our annuals, and especially with food plants, right? 1 year, they're going to pack on the biomass, but a plant has got to be able to protect that biomass. So that's where the microbial metabolites come in, and why you want a really, really robust and functioning microbiome down there in the soil. So does this look familiar? Regenerative practices, Dave talked about them in farming, and in gardening, we can do that too. Drop our shovels, cover the soil, and grow diversity. All right, I just want to say a few words here before I head to the last slide. The hidden half of nature is also about the human microbiome. There's a parallel place in our bodies to the Rhizosphere, and that would be our gut, especially the lowermost part of it. And so there's lots more stories about our own symbioses with the microbial world that you can read about in the hidden half of nature. And our microbial communities, of course, they have a preferred diet. It happens to be whole plant foods. And you can read, I'll say no more. Yes, we can have occasional donuts, but you want to just make sure that your microbes are well fed and happy, because they too are producing metabolites in our gut that get into our bloodstream and affect our well-being in a number of different ways. All right, so here we go. Here's your wrap up. You've been seeing a lot of things between farms and gardens and microbes. I'm going to sum it up here. When it comes to microbiomes, you've got your rhizosphere there on the left. We've got the human body there. Nutrients, lots of talk about nutrients. I think you understand that. And I hope you know, and this is something we go a lot more into in What Your Food Ate. A nutrient is not just a carbohydrate or a fat or a protein. It's this whole world of compounds and molecules that we need for our health, for our well-being, for not just growth, but for taking care of all of that growth. And that's where the microbial metabolites come in, because they help on that front. This has a huge amount to do with immunity and defense, whether you're talking the green body of a plant or the human body. And lastly, I think this is some of the highest forms of intelligence that we have out there. And I mean that in every sense of that word, because microbial metabolites, nutrients, these are forms of intelligence that the plant body and the human body can pick up on and also act on. So with that, I will turn it back over to you folks, and just remind you to look for this new book here coming out later in the spring. All right, thank you. And David's going to come back in here, I think, for some Q&A.
All right, if anybody has any questions, you can submit them through chat. Tom?
Yeah, there's currently no questions in the chat, so I encourage you to type in your question if you have one, so we can get some answers.
Well, my question for you, Anne, is what was the time frame from the Garden of Despair to the Garden of Hope?
I would say that we put that garden in, well, first I need to say, you all know a garden is never done. Hope goes on, and despair can go on and on too. But overall, I would say that by about year 5 of that garden, which would have been maybe around 2007, 2008, something like that, things were well on their way. And as time has gone on, my love affair with organic matter has never ceased, but I am now challenged with an abundance of it. And I sorely hate to be putting that in the yard bin to have it trucked off. But I have actually, and maybe you've done this too, I've used a little too much mulch at times, and I ended up losing a tree because of that. So you have to think about the soil, I think, as having sort of a rate of metabolism. And so don't be applying too much mulch at a time of year that, you know, it's not breaking down at a rate that your plants can take it in. So the journey continues. Organic matter still is going into the soil. Exudates are going into the soil. And I hope that goes on for quite a long time more too.
Also, can you talk a little bit more? Do you use cover crops in your home garden, and ones that have been successful, perhaps?
Yeah, the way I think about cover crops, it's really different for food beds versus perennial beds. And the way cover crops work in a food bed is because you've got these annual plants, and you know that you're going to be pulling them or cutting them at the surface and leaving them down. A cover crop in a veg bed is a really different thing than what I consider a cover crop in a perennial bed. So a cover crop in a veg bed is going to be, nitrogen fixers are great. Any kind of leguminous sort of plant, a clover or something. You plant that, you get that in there, and then you make sure it doesn't, you know, take off and take over your veg bed. So that's how I think about a cover crop. And I might, you know, fall or winter around here is a good time to sow that kind of a crop, because then it's coming in and providing nitrogen through the winter, maybe where your veg crops aren't growing as rapidly, and then you leave it in there in the spring through the summer if you want. With my perennial beds, and the whole reason for cover crops is you want exudates dripping year round, right? The microbial communities need to be fed year round. So that's what a cover crop can do where you're growing annuals. But in my perennial beds, the trees are sort of the cover crop, or other perennials are cover crops. So that's really what I'm looking for, is to have exudate production year round, no matter what kind of bed I'm talking about. And yeah, so I hope that kind of helps thinking around cover crops.
Oh, great.
We have a
Tom?
couple of several questions now, if you'd like me to read those, Gail.
Yeah, please go ahead, Tom.
Okay. First question is, for a garden that contains both beds that change crops and beds that don't, for example, perennials and shrubs, would mulching benefit the non-changing beds? And how do you deal with the slugs and snails under the mulch?
Yeah, good question. I think I addressed that a little bit with what the definition of a cover crop might be in a perennial bed. And as far as mulching, yeah, I do that. I always want, 3 or 4 inches of mulch on all beds. And so as that stuff begins to break down, and I talked about the metabolism of the soil, it starts to get thin. I put more mulch on these perennial beds. And I think here in the Northwest, we know which plants are going to succumb to slugs and snails and which ones aren't. So I make my plant selection choices carefully, and I'm not going to put candy out there, so to speak, for all of these slugs and snails. So, right, I've got that pretty much figured out, what's going to be edible to those kinds of pests and what isn't. And this is where it gets a little tricky on a vegetable bed, because we want to eat that food. We don't want our slugs and snails to eat that food. So what I will do with respect to mulch in a veg bed, because I do use mulch on a veg bed, is early in the season, when we're still getting a lot of rain and I'm not too worried about the soil drying out, I'll push mulch away to the sides of the bed and away from the plant, because it sort of creates a sort of moat, if you will, between where that mulch is, and then I've got a little bit of bare soil, and then you get to the plant. The slugs and snails don't so much like to cross that mulch area, and maybe they'll hang out over here in the mulch. And I don't mind them munching on the mulch and leaves and stuff like that, because they're one of these, macro decomposers. They're part of the deconstruction crew there. But if I find them anywhere around my plants, I'm going to kill them. I will smash them. I will pick them off. I use hand removal methods there. So what this involves, of course, is you got to be out there during early, kind of anytime spring starts and plant growth is really coming on, because slugs know this too, and they'll start appearing. So getting on top of what they're doing and paying close attention, because you can save or lose germinating seedlings and young plants in just a couple nights if you let down on that. So yeah.
Okay, another question. I garden in raised beds year round with high density. It's very challenging to do cover crops because I keep rotating crops in. Any suggestions?
Yeah, we learned a lot from our regenerative vegetable farmers out in Connecticut and California. There's more on them and what your food ate. And what they will do is they will, for one part of a growing season, sometimes the whole growing season, instead of putting their cash crop in a bed, they will do 100% cover crop on that bed, and they're really getting exudates back into the soil. And then they'll also, with that cover crop, when it's time for their cash crop, maybe the next season, they don't till that stuff in. They'll cut it at the surface, and then they lay that as mulch and let it decompose a bit, and then they plant through that. So that is one suggestion. Now it depends on, if that's not going to give you enough food production, I realize you're probably not a production vegetable farmer, and you might not want to do that, but maybe you could do that on a quarter of a bed or a third of a bed, and be sort of rotating things that way.
So that a follow-up question, which I think you may have answered, is it better to dig in the cover crop into the soil or remove it and add it to the compost? Or as you suggested, just cut it and leave it on the surface?
Yeah, that's what I generally recommend. And we know here, you cut green material cover crop around here, and it's not going to decay, in spring or early summer for the most part. It's too wet. Decomposition hasn't really started. But that's what I do. It helps keep moisture in the soil, and it also cuts down on labor. I mean, cutting this stuff, taking it, doing something else with it, letting it decompose, bringing it back to the bed, that's just human labor. So if you have the heart for it, and some people, and I don't know that this happens out on the islands, but you know how it is in a city, and some people, they think, oh, that doesn't look very nice. Like, that's not tidy. Well, you just sort of have to develop a look for that. And if my cut organic matter, from whatever starts to look like, oh, that's kind of looking kind of cruddy, kind of crappy, you just go over there and you give it a little stir and freshen things up, and it'll look much better. So I like to do that too. And as you are trying to get this cut green material, say from a cover crop, to decompose, and I know you guys get like hot sunny days out there on the island, or you can in the spring and early summer, I'll go and look at things, and especially if I've pulled something up by a root and I'm like, okay, I really need this to die, I need this to not take off again, I'll go and I'll upturn roots and expose them to the sun to make sure that they're, truly on their way to decomposing. So that's another little thing that I like to do with, I guess I'd call it, leave the organic matter in place, but manipulate it a little bit.
So another question relates to cover crops again is what you do to keep them, well, not to keep them from going to seed, but if they go to seed. If they go to seed, do you cut them and bag them if they're invasive like ryegrass, or or do you prevent them from seeding by cutting them while they're blooming?
Yeah, I think what Dave was talking about with some of these farmers, they'll go and put their, like many of them, they put their cover crops in mid to late fall, especially ryegrass. Rye comes up and it grows really well. And so they get back into their fields in the spring and they cut. And when they leave this cut material, which they call residue, laying on top of the bed. So you definitely want to get in there before things go to seed. And depending on how much, if you have a small little area and you find, oh, okay, gee, that's too bad this thing went to seed. Okay, so we're gardeners. We pull plants up, right? So that's how you're going to deal with that. You're going to pull that up, you're going to lay it root up so that the sun hits it, and that's the end of anything going to seed. But you want the carbon and nitrogen that's hanging around in that freshly pulled plant. You want that, on site on that bed to get back into the soil.
Another question relates to whether that would work for grass as well as conventional cover crops like clover and whatnot.
Yeah, definitely. That will definitely work. Now, clover, we all know clover can be pretty tenacious, pretty easy to grow around here. So that's one that, depending on what kind of clover you have and how much you want to keep it around, you can cut clover at the surface, right? And some clover will die, but some of it will spring back. And if you cut your clover at the right time, which is to say, you want this is in the context of, say, a vegetable garden, you cut that clover at a time that your young plants are coming up. The young plants are they're going to start putting growth on, and they're going to start to sort of provide some shade for that clover. And the clover, if you've timed things right, it's never going to take over your vegetable plant or your vegetable bed. If it starts to get too rambunctious, though, what do? We cut that off at the surface, and you let your vegetable plants, that's what this is about. You let them have full access to the soil and the nutrients and all of that. So, all of this is really a dynamic kind of a process.
So as far, again, cover crops, what are your favorite cover crops for your garden?
Yeah, I have mostly used just clovers. Quite honestly, I like the fact that they're returning nitrogen to the soil. Dave, I don't know if you have any comment on that as far as what cover crops, some of the farmers are using.
No.
Yeah, well, I know some people are fond of using something like buckwheat.
Or rye.
Yeah, rye, we hear a lot about. The interesting thing about grasses, I learned this actually, we were giving a talk at a wine conference, and one of the other speakers commented that grasses, he called them real leakers. And what he meant by that was that grasses tend to produce a lot of exudates. And that may be because there's not a lot of biomass for a grass plant that's above ground. Most of it is below ground. And so as a consequence, they've got a lot of surface area to produce exudates. And so a lot of exudates mean some really well-fed microbial communities. So that's another way to think about what it is you want your cover crops, to be doing. If you're looking for above ground residue, then look for, something really leafy and big that you can cut and leave on the surface. If you're looking to feed microbial communities, maybe some of these plants with more extensive root systems so that you're going to get more exudates there out into the soil. And of course, the thing about farming and gardening, right? What works for me here in my garden, you've got a different microclimate and a different set of conditions up there on the island. So it also comes down to, well, what have you observed that's growing well, not becoming obnoxious, and requires, a minimum of labor for the effects that you want.
Great. Here's a question for David. You talked about the comparisons between regenerative farming and conventional farming. Did you, during that process, did you come up with any data relating to industrial organic farms?
Yeah, we did. One of the comparisons we did, the one in California, it's from Sebastopol, California, was comparing the regenerative farm to two different fields on an organic farm. One, and it was what we would call an industrial organic farm, heavy tillage, organic, but very disturbed soil. And there were two fields there, literally right next to each other, that one of which had been organic certified for a number of years, I think 5 or 6, if I recall. And the other one, they literally were just converting. So it had been a conventional horse pasture for years.
Yeah, years.
And was just being converted to organic. So we considered that sort of the comparison of a conventional field. And then we had the industrial organic field and we had the regenerative field. So that's the one where we had a comparison with industrial organic. And the regenerative, it was cabbage was the comparison crop for those fields. And the regenerative cabbage was much better than either the industrial organic or the conventional. And the soil on the regenerative farm was much better than either as well. The industrial organic, both the soil and the cabbage was better than the conventional. So it was sort of a 3-step in the way. It actually made a lot of sense in terms of a 3-step thing. And the problem with a lot of industrial organic farms is they're heavy on tillage.
Right.
So that they disrupt a lot of the mycorrhizal symbioses that Ann was talking about. And one of the things we do in What Your Food Ate is we go back through the literature of all these studies that have looked at comparing the nutrient density of organic and conventional foods. And one of the key weaknesses of those studies is that they'll, any kind of organic farm is organic and any kind of conventional farm is conventional. So Gabe Brown would be a conventional farmer in one of those studies because he's not certified organic. But he's way out in the spectrum of really good regenerative practices. And this industrial organic farm that we had the comparison with would be in the organic pool. So there's a lot of difficulties that arise in just sort of the blanket comparisons of organic to conventional because they're not being standardized by soil health. So Ann and I published a paper, I think in November, that made the argument that what we really should be doing is comparing things based on soil health. What's the state of the soil? And in that sense, I think that some organic farms would look a lot worse than other organic farms. Some conventional farms would look better than other conventional farms. So that there's it's sort of an added wrinkle in terms of whether there's not a really good consumer signal in a store, in terms of you see something labeled organic produce, you don't really know how that organic farm actually grew the stuff. So I think there's a lot to be said for actually trying to know more about what the farmers who are actually growing your food actually did to their land when possible.
Great, that's a good answer. That sort of wraps up all the questions I have here. So I'll hand it back to you, Gail or Dixie.
Okay, yeah, thanks, Tom. One really quick question. This is probably for David. Boy, the farmers here, they tell me, oh, I can't do no-till because you have to spray herbicides to terminate the cover crops. And they have a million excuses why they can't do this. This is the way we've always done it. So what is happening in academia, hopefully to teach new farmers, hopefully these young kids are coming up. I apologize, master gardeners, but we were also taught to dig stuff in. So, it's not really new thinking, but it's new education. Are you seeing a change?
Well, and there's an element of new thinking to it in the sense that if you look at a lot of traditional farming practices, cover crops and crop rotations are really old ideas. I mean, there's absolutely nothing new about those ideas. But what's pretty new is combining that with no-till. And a lot of what allowed no-till farming to really take off was the development of glyphosate resistant, genetically modified crops. So you could spray them with glyphosate, kill all the weeds. And then your weed control problem was handled chemically. So I spent a lot of time in Growing a Revolution sort of walking through, well, what are the options for farmers to not, can you do no-till without herbicides? And the short answer is, yes, you can. And it works really well, but it's not being taught. And it's because it's you have to do things differently. So you have to think more about the sequencing of crops. You have to basically deal with cover crops as a way to, if you think of cover crops as a weed, you're not thinking right about it. But if you think of weeds as cover crops, as long as you kill the weeds before they go to seed, that can work. So one of the farmers that I interviewed, David Brandt, sort of joked that he plants weeds. He calls them cover crops. And so it's really in sort of how you manage the growth sequencing through the year of what's growing on your fields. And so, in terms of trying to convince farmers how they could do things differently, there's mechanical devices that are used to terminate or kill cover crops known as crop rollers, which are very clever. I talk about them in Growing a Revolution. There's ways to use sort of sequencing. Some people just mow down, let their fields go, plant them in cover crops, and then you literally cut it down and turn it into mulch as you plant your cash crop. So there's ways to get around it, but the easy button for no-till farming is herbicides. But you don't have to do it with the easy button. So I like to think of farming smarter rather than farming easier. And the biggest obstacle I've found to adopting regenerative practices is that sentiment of, well, we've always done it this other way. That'll never work here.
Right.
Well, if you don't try it, of course it won't work. But the other element that I found in every region that I visited and interviewed farmers is that they had to experiment and tinker to figure out what actually did work for them. So there's no sort of blanket recipe like there is with glyphosate for herbicides. Buy the patented seeds, buy the glyphosate, you're done with weed control. The only problem is it does compromise the mineral content of your crop as well. But we talk about that in What Your Food Ate, that whole angle. But there's different ways around it. But figuring out what would work on Lopez might take a little experimentation. So one of the crop advisors, a regenerative crop advisor who I respect very much, basically always advises farmers who are thinking about trying these more regenerative techniques to experiment with like one field, the one corner of their farm for a couple of years to figure out how to make it work for them before they go whole hog into it. Because nobody wants to risk the farm on a failed crop because you adopted some idea that didn't quite translate to your place. So I think tinkering and experimentation are the hallmarks of the farmers I found who were very successful at adopting these regenerative practices. And the beauty of it is you only need one or two of them in a region to figure it out, and then they can tell everybody else how to do it.
Right. Yeah. And one of the things that has worked really well with some of these conventional farmers who are transitioning into regenerative or curious about it, or who maybe, like you said, Gail, oh, that'll never work here. They do farm schools. So there's one farmer that has figured it out for a particular locale, and they put on a farm school. These farm schools are, typically in the growing season, sometime in the growing season, and they get on their tractors and they do their thing. Okay, here is, here's my planter, and here's how it punches through the residue to put a seed down into the soil where the seed will have contact with the soil and germinate, or here's my technique for this or that. And it's really farmers, just like gardeners, right? Do we go call somebody in Kansas to say, how should I grow a sunflower? No. You look at how your fellow islander or neighbor is growing sunflowers and saying, wow, mine all died. What did you do different? And then you steal that idea, right? And you go back to your place and do it. So that, and most farmers and gardeners, we're really willing to share information, right? At heart, we all have plant lust. somewhere deep down, right? Maybe it's tiny, maybe it's big, but that's why you learn, right? It's the monkey see, monkey do, and that is also, you know, who we are at heart of it. So if you've got even one farmer on the island who's tinkering around with this stuff, and like Dave said, try it on a little tiny part of their field, or maybe there's a demonstration site somewhere that somebody could start up. Yeah, change is hard.
Yes, yes. Well, Anne and David, thank you so much for taking time out on your Saturday. One of the few, well, at least it's not raining here. So quickly go out before it starts again. And I can't wait until your new book comes out. Hopefully we'll get a copy soon. Do you have a approximate date?
It'll be this spring. So they're available for pre-order on Amazon or any bookstore at the moment. The publisher says they will have hard books in April or May. So it'll be probably late spring before it's really distributed. But we're literally, what we do after this call is we go and we start working on the second half of the page proofs that are due back at the publisher next week. And it turned out great. I mean, it was a lot of research to try and pull this together, but you can really connect how the way we treat the land affects soil health, and that translates into crop health, livestock health, and human health. It's a complex, messy pathway, of course. You think of all the things that can affect our health. It's not just our food, obviously, but there is a line that you can connect that really highlights the sort of empirical wisdom of some of the early pioneers of organic agriculture that had figured out the connections, but had no idea how it actually worked. And science has filled in a whole bunch of the gaps in the last 50 years. And there's a pretty compelling, I think we make a pretty compelling argument for the need to reform global agriculture and based on science.
And care for our teeny tiny livestock.
Correct.
All right. Thank you so much again, guys. Have a great day. And I guess I'm turning this over to Lena.
All right.
Okay, well, thank you all
Yeah.
very much. It's been a pleasure
Thanks,
talking to you.
Dutch.
Bye.